Welcome to my Introduction to Networking course, also known as ITN. This is the version 7 material preparing learners for the Cisco CCNA 200-301. Cisco curriculum, everything is owned and copyrighted by them. So let's talk, how do we save our configuration? If you are doing the configuration, it is stored as a running configuration. The issue is if the device restarts, anything that's running that hasn't been saved will not be there. So we need to actually save the running configuration. We save it to the startup configuration. The startup configuration will be the config that the device will actually load. The running config will be the actual configuration as you've modified it. If you've not saved the running configuration and it is rebooted, whatever startup configuration is there is what will load. So how do we save it? In a global config, we can do not in a global config. If we make any modification in our global configuration, we should be saving our config. We do the saving by going to our privilege exec mode and typing copy running -config space startup config. Or you can do the shorter version, which is copy run start, hit enter, and it will save the configuration. If there are changes made to the running configuration and it's not saved, when there is a reboot, the changes aren't there. If you issue a reload, the reload will actually restart the device, and the reload will actually load the startup configuration. If you want to delete the startup configuration, again from our privilege exec mode, you would type erase startup config, and that will blank out the startup config. Once you've erased the startup config, you need to reload or restart the router or the device so that it will load a blank configuration. Because again, when the device is turned on, it's whatever configuration it has in memory is known as the running config. So even if you erase the startup config, the device is still running the running configuration until you reload it. Again, there is a video which we're not going to be covering. So again, how do we actually save our output? We can actually, if we're using PuTTY, you can log all of the information in the terminal session. You can actually go through and copy and paste it into a text document. You can do session logging, you can disable logging, kind of just depends on what you want. We have Packet Tracer outlining how to do the basic configuration and how to do the saving, and how to configure a switch. Moving on, we're going to talk about how to configure our end devices with ports and IP addresses. So again, IP addresses are outside the scope of this video, so let's just assume we're given our IP addresses and we can issue them manually. If we're talking with Windows 10, we'd go to our network configuration and we would use the following addresses, and you'd manually type in the addresses. If we're talking IPv6, we again would be given the IPv6 address and the default gateway and our prefix, and we would use those pieces of information. Again, IPv4 and IPv6 are discussed in a later module. So here we're just talking our logical addressing for communication. Moving on, let's talk about ports and interfaces. So how do we plug things in? So we have copper-based switches, and these will use Ethernet cables. The Ethernet has an RJ45 on the end. These are copper. They're twisted copper all the way through. If we have a fiber optic connection, we actually have fiber cable. And fiber has multiple different types of media types and plugins. Kind of just depends on what type of device we have and what plug that we actually have connected to that device. Next, we have wireless. We have a lot of wireless devices. So one thing they all have in common is if we're dealing with copper, we have to have some type of network interface card with the appropriate interface, a NIC, N-I-C. If we have fiber optic, we have to have a fiber optic NIC with, again, the appropriate interface. If we have wireless, we'll have a wireless NIC. That allows us to connect to that medium using the choice of media. So to connect to a wireless network, we have to have a wireless card. To connect to a fiber network, we have to have a fiber card. If we have to connect to a copper-based network, we have to have an Ethernet card. Which, I mean, most network cards are going to be RJ45, which will be this copper connection, just because that's the basic standard. So again, the three types: copper, fiber, wireless. Copper is going to be the most prevalent, and that's going to be some type of Ethernet cable with a RJ45. If you're looking at like a phone cable, an RJ45 looks very similar to that, but a phone cable is an RJ11. It's slightly smaller than a RJ45 connection. So once we actually have a physical connection, let's say with copper, how do things communicate? They actually have to have a logical address assigned, hence the next section being configuring the IP addresses. So again, back to this screen. So how do we get to this screen? Well, first we're assuming we have to manually configure the addresses. We are assuming no dynamic address assignment is available, meaning there is no DHCP server running on the network. So, how do we get to this screen? If you're in Windows, we'd go to Control Panel, Networking Sharing Center, would be looking at some type of an adapter setting, and we would be looking at the properties of our network adapter. From there, we'd be going to the IPv4 settings, and that is where we can manually set our IP address, subnet, default gateway, and DNS. If we actually do have DHCP, we would leave them as obtain automatically, and that would be all we need to do. If we're talking IPv6, IPv6 actually has a dynamic address association without DHCP. That's outside the scope of this video. For some reason, we're going to talk about giving a switch an IP address this early in the course, so we can actually configure a IP address to a layer 2 switch for management capability. So if we go to our switch, go to our global configuration mode, and we go to interface VLAN 1, that's a virtual interface, and we can assign an IP address to that switch by typing IP address, type in the address of the switch that we want to give it, and the appropriate subnet mask. That should be the same IP address network that that switch is attached to. We actually have a lab doing basic configuration, configuring the switches, configuring the PCs, and setting up a switch virtual interface. Lastly, once everything is set up, we need to verify connectivity. So how we do that is by doing certain commands like ping and traceroute, which again is outside the scope of this video, which we'll be covering on our next video. So now that we've covered basic device configuration, and we've talked about how to configure addresses and how physical media connections and things of that nature, we should have the ability to do some basic configuration. So we're going to have a lab where we configure basic commands or basic features of a switch and router using basic Cisco IOS commands. We're going to set up topologies, set up our PCs, configure a very basic level switch configuration to reinforce kind of what we've learned. What did we learn in this module? We learned about the overall structure of the Cisco IOS. We learned about how to navigate the IOS, and we learned about the device mediums that will allow us to connect our in devices to other networking devices, again copper, fiber optic, or wireless. And we talked about basic IP addressing and how to allocate them both statically and dynamically to in devices. And that is it for this lecture or this module. If you have any questions, please reach out. Thank you.